Greetings once again. Thank you very much for subscribing. Thank you for liking. Thank you for sharing the videos. This is your tutor, Mr. Bongani Masango. I'm going to be doing the last part of naming of compounds. Okay, thank you so much again. And please don't forget to subscribe and share the video. Okay, so later on we'll be doing electric circuits. I hope you enjoyed the previous lesson and you will enjoy this one too. Thank you so much. Welcome back, guys, and thank you for joining us once again. Today we are just going to address a few issues here. Firstly, we just want to do this activity. Please, you can pause this video and then try it by yourself and then get back to it to check the answer here. All right. Okay, so I hope you get the following answers. Okay, the first one is going to be tin 4 fluoride. Okay, the second one is going to be iron 3 chloride. Okay, the third one is going to be dinitrogen trioxide. Oxide. And the last one is going to be potassium manganate. All right, please remember that this is manganate. How do you know? Because if you take these two back, it's going to be manganate iron. All right, there's a difference between KMnO4 and K2MnO4. All right, this one is obviously potassium and permanganate iron, and this one is potassium and manganate iron. You can see the difference. Permanganate is -1 and manganate is -2. Okay, let me give you something else quickly. All right, so can you kindly write down the following compounds? Write down the following compounds. Okay, now the first one is going to be aluminium cyanide. The second one is going to be nickel 2 bromide. And the last one, it's going to be sodium thiosulfate. Okay, can you kindly try these ones? Pause the video and then try and do these compounds. All right. Okay, I hope you get the following answers. AlCN3. Remember, aluminium, it's 3+, and then cyanide, it's -1, so negative. Okay, and then they are going to swap and then bring down. Okay, nickel, it's going to be NiBr2, because nickel, it's 2+ and Br is negative. Okay, and sodium thiosulfate, NaS2O3. Okay, well, why am I putting those brackets there? Anyway, we know that it is just because this has only one, it's plus 1, and this one is going to be what? 2. Okay, because it's S2O3 2 minus. Okay, then the 2 belongs to thiosulfate, the 1 belongs to this one here, belongs to sodium because it's a cation. All right, I just want to address a few issues quickly. As you might have noticed, at times for sulfate, I used F, and at times I used P. Okay, so I just want to address only this. I'm not gonna sulfate, sulfite slash sulfite, sulfur, use a P here, slash sulfur. Okay, these are just different spellings. Okay, these are just different spelling, English spellings. Okay, now the fate, this one, okay, the fight, in this case we can also add the fate here, sulfate or sulfate. Okay, so these are just, both are English, they are English terms. Okay, so it's just the F1 is the American English. Okay, and then the P1 is the British English. Okay, all right, so basically the F1 is also accepted by the IUPAC. Okay, so this is just the international, it's an organization for naming, also naming the compounds. Okay, IUPAC is the International Union of Pure and Applied Chemistry. So they also use this one. Okay, apparently or probably the P1 will not be used in the future, apparently. But for now, just know that these are just English terms that are used. All right, I wanted to also mention the nitrate and the nitrite part. Let me just mention the polyatomic ions, polyatomic ions containing containing oxygen. Okay, now let me quickly write them. Let's start with the sulfate, sulfide, and then the sulfur dioxide. Okay, I cannot put this. I'm only talking about ions in this case. PO4, 3 minus, PO3, 3 minus. Okay, ClO3 minus and ClO2 minus. Okay, so maybe I should just include nitrate and the nitrite. Notice now that this is what we call, I'm not going to write down, okay, maybe I should quickly. This is what we call the sulfate ion. Okay, whether you used a P or F there, basically it's the just English terms there. But maybe with time the P will no longer be applicable. So now this is sulfide ion, okay, and then this is chlorate ion. Okay, and this is chloride, and this is nitrate ion, and this is nitrite. Okay, I'm just trying to show you one of the ways in which you can memorize these polyatomic ions. I know that is not easy, okay, but you have to, okay. MnO4 minus, this is permanganate ion, and then this is manganate ion. Please note that these are what? These are oxygen containing compounds. Okay, sorry, oxygen containing polyatomic ions, okay, or simply ions that are containing oxygen. All right. But these are polyatomic ions. So you can notice that there's similarity in naming these two. For example, this is sulfate, sulfide. You see, because they all contain both sulfur and oxygen. Now I want you to notice the 8. Let's start with the 8. Okay, but this is not going to be applicable here, but let's just come here, 8, and then all of you will notice that the 8 in terms of sulfur and oxygen has a lot of oxygen, okay. In terms of the polyatomic containing sulfur and oxygen, it has a lot of oxygen atoms. You see there are 4, and then here there are 3, okay. Here there are 3 also. It has a higher oxidation state, okay. So once you see the name 8, it means it's the one containing a lot of oxygen, or it has a higher oxidation state as compared to its SO3, because you see both of them are polyatomic ions containing the oxygen, all right, sulfur and oxygen. And then you'll see the 8 are the ones that are having a higher oxidation state. All right, chlorate. Okay, so once you drop one oxygen, for example, you are going to have SO3, okay. Then what is going to happen? The name changes to ide now. You see, chlorate 3, you drop 1, the name changes to ide now. Nitrate 3 maximum, and then drop 1 oxygen, the name changes to ide. Okay, that's another way of remembering these polyatomic ions. And then the permanganate ion, you see, the permanganate ion, the difference between the two, unlike the 8 and ide here, the permanganate ion has a net charge of -1, and then oxidation state of -1. And then what about this one? Manganate ion has -2. So those are different. That's the difference between the two. Okay, for today, I believe that's it, and I believe that you have learned a lot. Thank you so much. We are going to start with another topic, which is electric circuits. I hope you are going to join us. Thank you so much. Don't forget to share, like, and subscribe. Okay, have a blessed day.